If you've ever sat and watched a virtuoso pianist play and you see their hands just totally blurring across the keyboard, you've probably wondered how it's even humanly possible to hit like 30 notes a second.
Right, it looks like magic. You just assume the power is all right there in the fingers.
Exactly.
Yeah.
But the actual biological machinery making all that sound possible it's operating under a totally different set of rules than you'd expect.
Oh, completely. I mean, it forces you to reframe what you're even looking at. You aren't just watching an artist up there.
Yeah.
You're watching one of the most insanely complex, high-speed biomechanical events our entire species is capable of.
Which is exactly what we're tearing into today for this deep dive. We're looking at some truly phenomenal source material, specifically the research that Dr. Christophe Delong and Kinexa present on piano virtuosity.
It's such a fascinating document.
It really is. Our mission here is to, look past the sheet music for a minute and explore the biomechanics, the neuroscience, the sensory loops that let a human being push their physiology to the absolute limit.
Yeah, the research they present really strips away the romanticism of the music. It shows you the underlying biological symphony, basically.
Right, because before a single sound wave even hits the air, there is this massive electrical and mechanical process playing out. So, okay, let's unpack this from the top.
Let's do it.
Because before the arm even twitches, the command has to start in the brain. And the sheer cognitive load of playing something like a presto movement, 30 notes a second, I mean, that feels like it should just crash the human operating system.
Well, under normal circumstances, yeah, it would.
Right.
If a pianist had to, consciously think about every single note, the delay in the prefrontal cortex would just make that speed totally impossible.
So how do they bypass that bottleneck?
That's what's so cool about the research presented by Dr. Delong and Kinexa. It highlights this profound neuroplasticity. The brain basically alters its own structural organization.
Wow.
So instead of managing individual inputs, it starts managing these massive, complex patterns.
So it's building a totally new infrastructure.
Exactly.
Because the source notes that the primary motor cortex, the part that maps to the hands, is actually physically larger in professional pianists.
It is, yeah.
But, and this is the paradox I found so fascinating, when you look at fMRI scans of virtuoso playing, there's actually a massive reduction in the activity of those motor areas compared to, like, a beginner.
Right, it seems backwards, right?
Totally.
Yeah.
How can the hardware be bigger but less active?
It all comes down to metabolic efficiency. So think of it like city planners trying to fix a terrible transit system.
Right.
A novice's brain is using all these inefficient, winding residential streets to get the signal from the brain to the hand.
Lots of stop signs, traffic.
Exactly. A lot of energy burned, a lot of noise. But intensive practice, it essentially bulldozes those streets and builds a massive, dedicated superhighway right to the target.
Oh, that makes so much sense. So the physical real estate is bigger because of the superhighway, but the traffic flows so smoothly that the brain barely breaks a sweat managing it.
Precisely. The neural pathways are so robust, the effort just drops to near zero. And to handle the bandwidth of two hands doing completely different complex things at the same time.
The corpus callosum?
Yes. The data cable connecting the left and right hemispheres, it actually physically thickens.
The brain literally upgrades its own hardware.
Yeah.
That's wild. And that brings up the sheer velocity of the signal, because when the motor cortex fires that command down the corticospinal tract, we're talking about nerve impulses traveling up to 100 meters per second.
Right. Driven by the intense myelination of those tracts, the myelin sheath thickens.
The insulation on the wire, basically.
Exactly. And it optimizes saltatory conduction.
Wait, what is that?
It's the way the electrical signal jumps down the nodes of the nerve fiber. It's optimized so there is zero signal degradation.
Wow.
By the time that command hits the neuromuscular junction and triggers the muscle, it is so incredibly clear that a pianist can strike a key 11.5 times per second with a single finger.
11.5 strikes per second with one finger.
Without losing any accuracy.
That is just absurd.
Right.
But, okay, let's follow that signal out of the nervous system and into the actual arm. Because this is where the anatomy gets deeply counterintuitive.
Oh, yeah.
We mentioned at the start of the deep dive that there are zero muscles in the fingers themselves. So how is the physical hand actually executing this lightning-fast command?
Well, the fingers are really just bone, ligament, and tendon. Like you said, they're the instruments, not the engines.
Right.
The true engines generating all that force are actually way up in the forearms. You have these long tendons crossing the wrist and attaching all the way down to the fingertips.
So it's basically a marionette system.
Exactly.
The puppeteer is sitting back in the forearm, yanking on these cables to make the fingers dance.
Yes, and that biomechanical distance is crucial.
Why is that?
Well, imagine if the heavy, bulky muscle tissue needed to generate that force was actually in the fingers. The sheer mass of the hand would make rapid, delicate movements totally impossible.
Well, you'd have these huge, heavy fingers. You'd be swinging hammers instead of flicking switches.
Right. Keeping the weight back in the forearm lets the fingertips stay incredibly light and agile.
Okay, but the document does point out there are a couple of tiny specialized muscles inside the hand doing detail work.
Yeah, the intrinsic muscles. You have the lumbricals and the interossei.
Right.
But they aren't doing the heavy lifting. The lumbricals, for example, they're deep in the hand, and they control this very specific plucking motion.
Oh, so like when you hear a perfectly smooth, connected run of notes, a legato.
Exactly. That seamless transition is mostly the lumbricals doing their job.
Okay, and what about the interossei and the palm? The source mentioned that Vladimir Horowitz, legendary virtuoso, he had visibly thickened interossei muscles.
Yeah, those muscles govern the lateral spread of the fingers. So when a pianist instantly stretches their hand to hit a massive octave chord, the interossei are doing that work.
Oh, wow.
And in someone like Horowitz, decades of those violent wide stretches literally hypertrophied the tissue. You could see it.
That's crazy.
But, you know, even with those adaptations, the real secret to speed at the keyboard isn't just brute muscle strength, it's energy economy.
Using that proximal to distal sequence.
Right.
So meaning the energy doesn't even start in the forearm. It starts closer to the core and flows outward.
Think of the physics of cracking a whip.
Okay.
The handle of the whip doesn't move very fast, but the energy cascades down the leather until the very tip literally breaks the sound barrier.
Right, the sonic boom.
A virtuoso uses a similar cascade. The initial impulse starts in the shoulder, transfers to the elbow, goes through the wrist, and snaps out through the fingertip.
So they're completely offloading the burden. If the forearm had to do 100% of the work for every note, it would just fatigue in seconds.
Exactly. By rolling the energy down the arm, the forearm flexors are really just guiding the momentum.
But even then, the forearm is doing an incredibly demanding job, which brings us to what might be the biggest physiological barrier to speed, muscle antagonism.
Yes. This is huge.
Because of how our skeletons are wired, every movement requires opposing muscles, right?
Right. To pull your finger down, the flexor muscle on the bottom of your forearm contracts. But the muscle on the top of the arm, the extensor, it has to do something too.
It has to instantly, completely relax.
Yes. Think about gripping a steering wheel. If you squeeze it as hard as you can, you feel how your whole forearm locks up solid.
Yeah, it gets super tight.
That's both the flexors and extensors firing at the exact same time to create stability. And that tension is exactly what a virtuoso spends years trying to unlearn.
Because if the extensor doesn't relax the exact millisecond the flexor fires, you're driving with the parking brake on.
It creates immense internal friction. So true virtuosity isn't just the neurological ability to activate a muscle fast.
It's the ability to deactivate it.
Instantly. The cycle has to be explosive activation, impact, and then immediate relaxation in a fraction of a millisecond.
Using the rebound of the key to reset, that is, okay, this brings up a massive question for me.
Sure.
If the mechanics of all this rely on optimizing muscle antagonism and thickening the corpus callosum and myelinating the nerves, is it just a numbers game? Like if I lock myself in a practice room for 10,000 hours and just drill these movements, does my biology eventually surrender and turn me into a virtuoso?
That is the assumption literally everyone makes.
Right.
But the general linear model studies presented in the Delong and Kinexa research, they kind of shatter the 10,000-hour rule here.
Really?
Yeah. Accumulated hours of practice do not significantly predict a pianist's maximum striking speed.
Wow. That feels incredibly unfair.
I know, right? But it highlights the reality of physiological ceilings. The data actually shows that innate baseline factors are much stronger predictors of peak velocity.
Like what?
Like a person's untrained finger tapping speed. Or, interestingly, the natural strength of their elbow extensors.
Elbow extensors.
Right.
The triceps. Why would that matter for finger speed?
Go back to the whip-cracking physics. To snap that energy down to the fingers, the elbow joint has to act as a perfectly stable fulcrum.
Oh, I see.
If the elbow extensors are inherently weaker, the fulcrum wobbles. The energy dissipates.
And your maximum speed drops no matter how many hours you practice.
Exactly.
Okay, that makes total sense. But here is the detail from the data that really threw me. Having too much grip strength actually decreases a pianist's speed.
Yes, the grip strength paradox.
Because I would assume a stronger hand equals faster, more powerful playing.
It makes sense intuitively, but high baseline grip strength is often correlated with increased resting tension in the hand and forearm.
Going back to the steering wheel analogy.
Exactly. If your default physiology naturally leans toward high tension, you have a much thicker neurological barrier to achieving that microsecond relaxation we talked about.
Right.
And the research shows this really hurts speed, especially during soft, delicate passages where you don't need raw force, you just need pure micro-coordination.
So just brute forcing your way through 10,000 hours not only doesn't guarantee speed, it might actually be dangerous. The source spends quite a bit of time warning about the dark side of procedural memory.
Yeah, it's a very real danger.
We know repetition maps the movement into the brain so you don't have to think about it. But there's a tipping point where that neuroplasticity actually turns destructive.
Yeah. You're referring to focal dystonia.
Right.
It's a form of maladaptive plasticity, and it ends the careers of roughly 1 to 2% of professional pianists.
I've heard the term, but I've never fully understood the mechanism. How does practicing too much actually break the system?
So inside the somatosensory cortex of your brain, there's a literal physical map of your body. Every finger has its own distinct segregated territory.
Okay.
When you practice, you reinforce the wiring in that specific territory. But if a pianist repeats a highly complex, forceful movement tens of thousands of times, say, violently striking a chord where the ring and pinky fingers fire together,
Yeah.
the brain, in its attempt to be hyper-efficient, starts to merge those territories.
Oh, wow. So the physical map in the brain literally blurs.
The borders dissolve. The representation of the ring finger and the pinky finger fuse into one zone. So then, the brain sends a command to move just the ring finger. But because the map is blurred, the pinky uncontrollably curls up as well.
The hands literally lose independent control because the brain optimized itself into a corner.
Exactly. It's a stark reminder that the brain's ability to rewire itself is amazing, but it's a blind biological process.
Right. It doesn't know what music is.
No. If you push it past its structural limits with excessive, tense repetition, it will rewrite the software in ways that completely corrupt the hardware.
That perfectly frames how delicate this entire high-wire act is. And I think that leads us perfectly into the sensory side of things.
Oh, the feedback loop.
Yeah, because everything we've talked about so far is about the brain pushing output down the arm. But a virtuoso can't sustain 30 notes a second just by shouting commands at their hands.
No, absolutely not.
The system needs a continuous, massive intake of real-time data to prevent catastrophic errors.
Right. A high-speed motor command is useless without an equally high-speed feedback loop. The pianist's nervous system is essentially this massive data processing engine, and the first layer of that input is proprioception.
Our sixth sense. The body's ability to track its own joints in 3D space.
Exactly. Even with their eyes closed, sensors in the joints and muscle spindles are constantly firing.
Updating the brain?
Yeah, updating the exact angle of the shoulder, the torque of the elbow, the micro stretch of the forearm. They don't have to look at the keys. Their brain has mathematically mapped the geometry of the piano to the geometry of their skeleton.
But the real magic, to me, seems to happen the exact millisecond the skin of the finger touches the ivory, because the source emphasizes that the fingertips are packed with these mechanoreceptors.
Innervated by beta axons, yeah.
Right, and the density is up to 4 times higher than anywhere else on the arm.
Which gives the fingertips a spatial discrimination threshold of barely 2 millimeters.
2 millimeters. I want to dig into how that actually works, because we always hear receptors, and we think of, like, little buttons in the skin.
Sure.
But how does a piece of flesh actually turn a 2-millimeter slip on a piano key into data the brain can read?
Okay, let's look at just one type, the Meissner corpuscle. It's this tiny, fluid-filled capsule just under the epidermis.
Okay.
Inside this capsule is a coiled nerve ending. When a pianist's finger hits a key, the physical pressure slightly deforms the skin. And that deformation literally squishes the Meissner corpuscle.
Oh, like squeezing a water balloon.
Exactly like that.
Okay.
And that physical squeezing pulls open microscopic ion channels on the nerve ending inside.
And sodium rushes in.
Sodium rushes in, generating a voltage spike. And the cool thing is, the corpuscle doesn't just register basic touch. It's highly specialized to detect dynamic slip.
So if the finger starts to slide,
Even by a fraction of a millimeter, the sheer force changes the squish of the capsule, which alters the voltage spike instantly.
and then that spike races up the spinal cord at 100 meters a second, hits the somatosensory cortex, and the brain instantly tweaks the tension in the forearm to correct the trajectory.
Before the finger even has a chance to slip off the key, all in milliseconds.
That is unbelievable.
But meanwhile, you have Pacinian corpuscles buried deeper in the skin doing the exact same thing, but tuned to the high-frequency vibration of the impact itself.
So they tell the brain exactly how much kinetic force went into the key.
Right.
And all of this mechanical data is being cross-referenced against the auditory loop, too.
Oh, constantly.
The ears are taking in the actual sound waves. The auditory cortex analyzes the pitch and volume, compares it to the idealized performance in their head, and sends a secondary wave of corrections down to the hands.
It's an overwhelming cascade of chemical, electrical, and mechanical data. It's staggering.
But when we watch a virtuoso, we don't see any of that struggle. We just see pure fluidity.
And this is where the neuroscience presented by Delong and Kinexa almost borders on the philosophical. Because when this massive feedback loop perfectly synchronizes, the brain enters what researchers call neurobiological grace.
The state of flow.
Yes. Biologically, it's a state of transient hypofrontality.
Meaning the prefrontal cortex.
The part of the brain responsible for conscious thought, self-monitoring, judgment, self-doubt, it literally powers down. It goes into standby mode.
Because conscious thought is just too slow. If the prefrontal cortex tries to micromanage a 30 note per second run, the system crashes.
Exactly. The conscious mind has to step completely out of the way. And when it does, cortisol and stress hormones plummet.
Wow.
The deeply trained motor networks take over. The pianist is no longer trying to play. The highly optimized nervous system is just executing its programming without interference.
That is the exact moment technique vanishes and becomes pure art.
Beautifully said. It really is.
What an incredible way to conceptualize it. I mean, to think about the absolute chaos happening under the skin, the bulldozed neural highways, the hyper-thickened corpus callosum.
Physics of a whip crack in the forearm.
Yes. All of it being dynamically steered by fluid-filled capsules in the fingertips, tracking 2-millimeter changes in sheer force.
And it all culminates in this profound mental silence. It frames the human nervous system not just as a machine, but as the ultimate instrument itself.
It really does, and I think that's such a powerful takeaway for you listening. Whether you're trying to master a Chopin etude, or you're literally just gripping your phone to type out a text message right now.
Which is pretty complex in itself.
Right. Your own nervous system is executing a microscopic miracle of geometry and electrical signaling right this second. Kind of makes you look at your own hands a little differently.
We're all walking around with symphonies of biological coordination happening beneath our awareness every single day.
Absolutely. And it leaves me with one final thought for you to ponder. We just established that a virtuoso only reaches their peak potential when their brain literally silences its own prefrontal cortex, right?
Right. They have to turn off the inner critic to achieve that flow.
So, what other demanding areas of your life might completely transform if you simply trusted your preparation and finally let your inner critic go to sleep? Next time you see a master at work, remember, the greatest trick isn't the speed of their hands. It's the fact that at the highest level of human performance, the mind has to completely stop getting in its own way.